So the next section is gas laws. And just a reminder, for gas laws, temperature must be in Kelvin. You will, not Inc, Kelvin, sorry. We will have a reference sheet. I don't have one right now, but I will explain why I'm choosing the equation I am. So, with pressure, which is P, volume, and temperature being known, the ideal gas law, I would go to my reference sheet, I would look for the ideal gas law, and it's PV equals nRT. So with pressure, volume, and temperature being known, the ideal gas law can be used to, if I know P, V, and T, I can find N. So that tells me N, which is moles, so I can find C. 17. During an experiment to produce carbon dioxide gas, a student recorded the following data. They have pressure of carbon dioxide, volume, and temperature. Now, they're trying to find moles. So we have P, V, we have N because we're looking for it, then we need R and T. We are using PV equals nRT again. P is that 708.1 mmHg. Because it's in mmHg, R is going to be based off of the pressure, so R is 62.4. Volume comes from our data, and volume is liters, which it has to be in liters, so that helps us. We don't have to convert. 0.02965 liters. Temperature, however, is in Celsius, and it must be in Kelvin. So I'm going to add 273 to convert it to Kelvin. When I do that, I have 298.5 Kelvin. So 298.5 Kelvin. I plug in my values, so 708.1 for P, 0.02965 for V. N is unknown, so it remains N. 62.4 times 298.5. Remember, there's more than one way to solve an equation like this when you're isolating for a variable. So what we can start off with is by multiplying. I'm just using my phone because I don't have a fancy calculator at home. So 708.1 times 0.02965, and you get 20.995 on this side, equals 62.4 times 298.5, so N times 18626.4. Remember, we want N by itself, so we're going to divide both sides, and we'll divide by the 18,626.4. That way we can cancel it out, which will leave N by itself. So 20.995 divided by 18,626.4 equals 0.00113 is what we get for our N, and N stands for moles. So closest one to this answer is A. So, sorry. Remember, I highly, highly suggest labeling everything with the variable. It helps a lot. Alright, 18. The volume of a gas sample is 200 milliliters, so that's a volume. When the pressure is 3 atm, pressure, and the temperature is 37 degrees Celsius. Even if I forget that ml stands for volume, it tells me the volume is. So I can use my awesome reading skills to tell me this is V, this is P, this is T. What is the new, so a second, all right, temperature, so I'm looking for a new temperature, if the volume increases 2, and remember, this 2 tells me this is my second volume. That means 200 is probably my first. And the pressure decreases 2, this is my second pressure, which means this is my first pressure. So, I have V1, P1, T1, T2, V2, and P2. When I go to my reference sheet, I can see the equation P1, V1 over T1, N1 equals P2, V2 over T2, N2. Now, you'll notice we don't have N up here, but that's okay. All we have to do is, in the combined gas law formula, if we don't have a variable, we just cross it off. Remember, I'm using the combined gas law because we have one gas changing. PV nRT, we only had one gas staying the same. Here it's changing. So I'll plug in my values, but before I do that, I have to convert temperature to Kelvin. So I'm adding 273. When I do that, I get 310 Kelvin for my first temperature. So I'll plug in P1 is 3, V1 is 200, T1 is 310 because it's Kelvin, and that equals P2, which is 2, times V2, which is 400 over T2. Remember, there's more than one correct way to solve this. So next, I'm going to multiply my top. So 600 over 310 equals 800 over T2. And then I'm going to cross multiply. So that ends up being 310 times 800 equals 600 times T2. And then I'll divide both sides by 600. So when I do that, the 600 cancels out. T2 is by itself. I'm going to use my calculator on my phone. I have 310 times 800 divided by 600. And that got me 413.3. Repeating, Kelvin. I look up here. Best answer is B. All right, here we have a data table. This question's asking about the data table. Which statement best characterizes the data in the chart above? So it's looking at how volume and pressure are related. So we can look at this column. Well, every time I move down, volume is increasing. So 12.8 to 22.6, it increased. 22.6 to 27, it increased. Then it increases again all the way up to 40. So here, volume is increasing. So it goes up. Pressure, though, it went from 40 to 22, so it decreased. And it keeps on decreasing all the way to 12.9, which tells me pressure decreases. So volume goes up, pressure goes down. This is indirect. So if volume went down, pressure would go up. Now let's look at our question and the answer choices. Let's look at A. The volume and pressure values are randomly related. Well, I can see that there's a pattern, so I don't think this is random. So random, no. As pressure increases, volume also increases. Let's look. When pressure goes up, volume went down, so that's not true because volume would have decreased. As volume decreases, okay, pressure increases. I see that's true right here. So I believe it's C, but let's just double check. the volume seems to jump around going up and then down. No, volume just keeps going up, so that's not a good answer choice. So C is my best answer. Next, we read through the question and we annotate. A sample of 899.3 milliliters of argon at 0.9 degrees Celsius has a pressure of 741 mmHg. What volume will the gas occupy at 25.6 degrees Celsius and 689 mmHg? Well, I've underlined my numbers. Now I'm going to assign the variable. Milliliters, that's a volume. Degrees Celsius, temperature. mmHg, pressure. 25.6 degrees Celsius, temperature. 689 mmHg, pressure. So it looks like I have a first volume, a first temperature, a first pressure, a second temperature, and a second pressure. I also have a second volume. That's what I'm looking for because it says what volume. So V2 is what I'm looking for. I'm going to use the combined gas law because I have one gas changing. So P1V1 over T1 equals P2V2 over T2. Why did I not write moles on the bottom? Because moles was not mentioned in my original question. So I'm going to plug in and solve. P1 is 741. V1 is 899.3. T1. Remember, temperature has to be in Kelvin, so we're going to add 273. So my T1 is 273.9 Kelvin. And that equals P2, which is 689, times V2, which is our unknown, over temperature. So I'm going to have to add 273, which gives me 298.6 as my denominator. Remember, there's more than one way to solve this. So I'm going to do all the math on this side, which means I'm going to multiply. My computer might just die. I'm going to multiply 741 times 899.3 divided by 273.9. So on this side I have 2432.93647. This we're dividing, so 689 divided by 298.6 equals 2.30743. So on V2, I want V2 by itself. These are multiplying, so I'm going to have to divide by 2.30743. That way, I can cancel out that side of the equation, leaving me with just V2. So when I plug in 2432.93647 divided by 2.30743, I'll get 1054.39, and my unit is the same as my original V1, so it's ml. So looking at the next problem, first thing I would do is what? If you said read and annotate, you're right. So I'm going to read through. How many moles of nitrogen dioxide will occupy 4.56 liters at 35 degrees Celsius and 3.12 atm? All right. Now that I've annotated by underlining, I'm going to label. Moles is in, liters is volume, degrees Celsius is temperature, and 3.12 atm is a pressure. Alright, so I've done that. Next thing I have to do is decide which equation to use. Well, I say I have moles in pressure, volume, temperature, so I'm going to use PV equals nRT. Now, I'm plugging in the computer. So it won't die, hopefully. Okay. So, a reminder, volume has to be in liters, which we are, so that's awesome. Temperature has to be in Kelvin. We're not, so we're going to add 273. And so I end up with 308 Kelvin. So I'm going to plug in pressure, which is 3.12, volume 45.6, moles we don't know, so N it is. R comes from ATM, so ATM, therefore R is going to be 0.0821. And where did I find my R? If you said the reference sheet, you're totally correct. So here's my R, and last would be my temperature, which is 308 because we have to be in Kelvin. I'm going to multiply, so 3.12 times 45.6, 142.27 equals N times 0.0821 times 308, which is 25.2868. I want to isolate for N. To do that, I'm going to divide both sides by 25.2868. So 142.27 divided by 25.2868 gets 5.63. I crossed these off because I wanted to remember that I canceled these out so that I'm left with N. So N is 5.63 and N is our variable for moles, so this is 5.63 moles.